Okay, we're going over 4.6 equivalent algebraic equations. So the main point in this lesson is that there are many different equivalent equations that can be used to describe any given line. And what we're going to take a look at are our basic algebraic properties. And those are going to help us see how we can prove two different equations that might look different, proving that they're actually the same thing. So our first property we're going to look at is the associative property. So this says A plus B times B plus C is equal to A plus B plus C. So let's just take a look at that with some numbers. So let's say we have 1 plus 2 plus 3, and we're saying that that is equal to 1 plus 2 plus 3. So from order of operations, we know we have to do whatever's in the parentheses first. So inside the parentheses, we have 2 plus 3, which is 5. So we have 1 plus 5 over here. And then over on this side, we have 1 plus 2, which is 3 plus 3. So is 1 plus 5 equal to 3 plus 3? Yes, both sides are equal to 6. And then the same thing with multiplication. We can multiply, we can say A times B times C, or we can say A times B times C. So for that, again, let's choose a couple of numbers. So let's say we have 3 times 4 times 5. And we're saying that should be equal to 3 times 4 times 5. So over here, again, inside the parentheses, we get 3 times 20. And then over here, we'd get 12 times 5. Well, yeah, those are both equal to 60. So that's how that works, okay? So what this is basically saying is that, like, the grouping, whatever we associate numbers with, we can associate them differently when we're using addition or multiplication. However, this does not work with division or subtraction. Okay, only addition and multiplication. Now let's look at the commutative property. So commutative, you can think about the word commute, which means to move around. So what this is saying is that if A plus B is equal to C, then also B plus A is equal to C. So that's just saying that 1 plus 2 is the same thing as 2 plus 1. They're both equal to 3. And the same with multiplication. If we have A times B, and that's equal to C, then the same thing, B times A is also equal to C. So like 5 times 3 is the same thing as 3 times 5. They're both equal to 15. And again, these only work with addition and multiplication, not with subtraction or division, right? Because 6 minus 7 is not the same thing as 7 minus 6, okay? Now we have the distributive property. This is part of our objectives for this lesson, is to really take a look at that distributive property. This is going to come in handy a lot later on in the course when we're doing something called factoring. The distributive property distribution is like the opposite of factoring. And what the distributive property says is that I can, if I have a number being multiplied by two numbers that are being added together, then what I can do is I can distribute that across both of them. So A times B plus C becomes A times B plus A times C. So let's take a look at that with some real numbers. So let's say we have 2 times 4 plus 5. So of course we could just add those together and then multiply. but we can also do this. We can also distribute. So let's first do it like if we were just doing order of operations. So we would have 2 times whatever's in the parentheses, which is 9. So that equals 18. But then by distribution, I also would get 2 times 4 plus 2 times 5. Well, 2 times 4 is 8, and 2 times 5 is 10, which is also 18. Okay? And the same thing, so the same thing can happen in the opposite way, right? We could pull, so if I had something like this, I had 2 times 4 plus 2 times 5, I could see that those two numbers here have a common 2. So that means I could pull the 2 out of each of those and rewrite it back again like this. So we can go both ways. And kind of dependent on the situation, one way might be, it might be more advantageous to distribute. And in another case, it might be more advantageous to factor, to pull out. And this, we're looking right here, we're looking with just numbers, but remember in algebra, we're going to be looking at variables a lot of the time. So this can be really, really useful when trying to solve for a specific variable. Right, and now let's look at our last property, the identity property. So this is saying that for addition, if I add 0 to any number, so if I have a plus 0, that's the same thing as saying 0 plus a, and those are both equal to just a. So 0 plus any number is always going to be that number. And then similarly for multiplication, if I have a times 1, that's the same thing as saying 1 times a, and that's always going to equal a, because 1 times any number is always equal to that number. Right? So we're going to be using these different properties to convert between all of our different linear equations. So we have 4 different styles, 4 different forms of writing a linear equation. The first one we learned was intercept form. That is y equals a plus bx, where a is the y-intercept and b is our slope. Then we learned slope-intercept form, which is very, very similar, just kind of flip-flopped. So we have y equals mx plus b, where m this time is our slope and b is our y-intercept. So just like up here, how I used different numbers in place of a, b, and c, down here, when we look at these letters, they could mean anything in the world. So, I don't know, that can be a little bit confusing when looking at these different forms, how in this one b is the slope and in how this one b is the y-intercept. So I just want you to know that these variables can stand in for any number. And the main point for these two forms is to think about how the slope is the coefficient of x. It's being multiplied by x. The slope does not include x. It's only the number, only the number. And then this number that's being added to it, that's our y-intercept. Okay, so it doesn't really matter what the letter is. We just need to know how it's functioning within the equation. All right, now we have point slope form. This was the last one we learned about. This is, again, y equals y1 minus b times, oh no, it's b plus. It's y1 plus b times x minus x1, where x1 and y1 are our x coordinate and a y coordinate of a point on a line. So x1, y1 is a point on our line. And then again, b is our slope. Right, and then one last one we have is standard form. And this just looks like this. We have ax plus by equals c. And standard form it's a little bit different because it doesn't really break down this way. But there are certain times where it's really useful to use this. Cool. So those are our 4 different forms: intercept, point, slope, intercept, point, slope, and standard. You'll notice that these 3 are all solved for y. They're all solved for y. They all start with y equals something. Standard form is the only one that has x and y on the same side of the equal sign. Okay. All right, let's move on. So we're going to take a look at one of our objectives. I can learn and use the distributive property. So we're going to use the distributive property to write y equals 2 times x plus 4 without parentheses. Right, so I'm going to remind you what our distributive property looks like. It's a times b plus c is equal to a times b plus a times c. So let's use that up here for this equation. So we have y equals 2 times x plus 4. So this looks like it's in point slope form. Looks like it's in point slope form. So where this would be my slope, this would have been my x1, and then my y coordinate, I should say my x coordinate. My y coordinate doesn't seem to be there, which means that it is 0. So then I know that my slope of this line is 2, and then a point on the line would be, my x coordinate would be -4, and the y coordinate would be 0. The x coordinate is -4 because I have a plus sign right there. And my formula, my point slope formula, says y1 plus b times x minus x1. So if x1 is positive, then this should show up as a subtraction sign. But if x1 is negative, this would turn into a plus. So I know that my x coordinate here would be -4. But now what I want to do is I want to use the distributive property to rewrite y equals 2 times x plus 4 without parentheses. So let's give that a try. So we again have y equals 2 times x plus 4. My distributive property says I can distribute this across both of those. So I get y equals 2x plus 8. 2x plus 8. And now this is written in slope-intercept form, where y equals mx plus b, where still my coefficient is my slope. And now this is my y-intercept, right? Let's go on to example B. So we want to be able to rewrite equations to determine if they are equivalent. So we have 2 different equations here. This one is written in point slope form, where this one is written in standard form. So what we're going to do is we're going to change both of them so that they're written in intercept form or slope-intercept form. So for this equation, y equals 2 plus 3 times x minus 1. we're going to use the distributive property to rewrite this without parentheses. So this 3 is going to be distributed to the x and to the -1. So we get y equals 2 plus 3x minus 3. And then I can combine my like terms, and I'm left with y equals -1 plus 3x. Okay, so that's intercept form. I'm going to try and write it in slope-intercept form. That would just be, just flip them around, where 3x comes first, and then -1, the slope-intercept. All right, so let's give the other one a try. We have 6x minus 2y equals 2. And again, we're going to change this to be in slope-intercept form. So the first thing I need to, so what I want to do is I want to get my y all by itself. So I'm going to first get rid of my 6x. I'm going to move that over to the other side. Since this is positive, in order to undo it, in order to move it over to the other side, I need to subtract it. So I subtract 6x over there, which means I subtract 6x over here. 6x minus 6x cancels out, and I'm left with just -2y equals 2 minus 6x. And now I want to get rid of this -2, so I'm left with only y. So between this -2 and the y, there's that invisible multiplication sign. In order to undo the multiplication, I divide by -2. If I divide this side by -2, that means I have to divide this whole side by -2. These -2's cancel out, and I'm left with just y on here, over here. And then I have 2 minus 6x divided by -2. So this can be rewritten as 2 over -2 minus 6x over -2. I just broke that up. So now I'm left with y equals 2 divided by -2 is -1 minus 6x divided by -2 would be -3x. So it's going to -3x. When I subtract a negative number, that turns them both positive. And now if I just rewrite it, I just move it around a little bit to get it in slope-intercept form. I get y equals 3x minus 1. And I can see that that and that is equal to each other. They're the same exact thing. So therefore, these two equations are in fact equivalent. Right, we have one more example we're going to go over, but before we do that, we're going to look at the properties of equality. So these are more algebraic properties that we use all the time. And we tend to take them for granted, but in actuality, mathematicians in the past spent many, many hours proving why these are true and establishing them as properties so that we can use them in order to solve equations. So our properties of equality are saying that for any two numbers or two expressions that are equal to each other, saying that if we add a number to both sides, the whole thing remains equal. Similarly, if we subtract a number from both sides, they both remain equal. So let's just say we have, let's say A is equal to 2 plus 3, and B is equal to 1 plus 4. We can agree that those are equal to each other because both sides simplify to 5. So if I had 2 plus 3 equals 1 plus 4, and I decided to add 6 to both sides, well, that still is equal, right? They're both still equal. I know the values change, that now they're both 11 on either side, but this equation is still equal. Same thing if I did 2 plus 3 minus 4, that still would equal 1 plus 4 minus 4. They both equal 1 now. Same thing when we multiply. If I have 6 equals 6, and I multiply both sides by 2, this equation is still true. It's still equal. Same thing with division. If I had 12 equal to 12, and I divided both sides by 4, I would still get 3 on both sides. The equation is still equal. The reflexive, this is something that is really kind of obvious. If you have 6, of course it's equal to 6. And same thing up here, that's what I used. I said 2 plus 3 is equal to 1 plus 4. Yeah, of course, because 5 is equal to 5. And then the symmetric rule, so that's just saying 2 plus 3 is equal to 3 plus 2, right? And then transitive, if A is equal to B and B is equal to C, then A is also equal to C. So if, let's use some variables this time. If X is equal to 2 and 2 is equal to 1 plus 1, then X is equal to 1 plus 1. Okay? So we're going to use those properties in this example. What we're going to do is solve this equation and identify the different properties we use in each step. So we have 3x plus 4 over 6 minus 5 equals 7. So I'm going to solve this by undoing. The first thing I need to undo is this subtracting 5. So in order to undo subtracting 5, I need to add 5. So if I add 5 over here, that means I have to add 5 over there. These cancel out, and I'm left over here with 3x plus 4 over 6 equals 12. Well, I used my addition, the addition property of equality. So I used addition property right there to do that. And now what I'm going to do next is I'm going to undo this division. I'm going to get rid of this 6. To get rid of this 6, again, I undo division, which means I have to multiply. So if I multiply this side by 6, I also multiply that side by 6. These 6's cancel out, and I'm left over here with 3x plus 4 equals 12 times 6, which is 72. And what I did here, I used the multiplication property. Now I have 3x plus 4 equals 72. So I need to get rid of my 4. In order to get rid of the 4, I need to subtract 4. I need to undo this addition. If I subtract 4 over here, though, I have to subtract 4 over here. And that is by the subtraction property. So these 4's cancel out, and I'm left with just 3x equals 72 minus 4, which is 68. And now, last step, I need to get rid of my 3. Between this 3 and the x, there's that invisible multiplication sign. In order to undo multiplication, I need to divide by 3, which means I need to divide by 3 over here. And then I'm left with, and I do that by the division property, which says that I can divide both sides by the same number and the equation remains equal. Over here, those 3's cancel out, and I'm left with just x equals 68 over 3. And that's my answer. Right, so again, I hope this video was helpful. If you have any questions at all, please let me know. You have some practice problems to do, as well as a check for understanding. Those are all in your Google Classroom. Let me just pull it up. Algebra 1 classwork. So this was 4.6. Again, read through the notes. Go back and watch the video if you need more help. If you need to go back over it again, go back, rewind. That's what this is there for. And then there's some practice problems to do, as well as a Google form to answer. If you have any questions, please reach out. All right, I hope you're having a great day. Thanks for watching.